Yeah, so in case you haven't been to the last session, the firefight chat, I'm Brigitte Mathiak, and this is Uwe Schindler and Ming-Fang Wu, and Fotis is not. Oh, I'm standing in front of you, so now everybody can see. Sorry, he's not in Costa Rica. Yeah. Anyway, so Uwe.
Yeah. So, hi, welcome everybody. So, let me see. Okay. So the first thing I want to introduce you is it would be good if everybody could open the collaborative notes, also the online people. The link is here as a QR code, and but you can also use that short link here. And it would be nice if you would add your own name there, that you attended the meeting for us. If you want to ask some questions for the online people, please use the Zoom chat. We will check it out. So Mingfang will look into the Zoom chat, I think, or I will also do it in parallel. So just ask your questions if you have anything. The session is recorded here, so everything you say will be on tape. So the meeting objective today is to update you and the online people about the group process. And the second part of the meeting is to discuss about the usage of AI in data discovery, which was not yet covered in that group. So we want to discuss about what we could do in the future to also introduce AI into our maybe the 12, as in the joke we had in the morning about the 12 rules. So AI is still missing there. So that could be one opportunity we could look into. So the agenda is now, the first one is the introduction about the group, which is done by, who is doing it? Mingfang will do it? No, you. The introduction of the group. Yeah. Yeah, you will do it.
So the group, as Bridget already said, in adoption session, we focus on the data fundability. So it's in the data fair data principle. It is stated that metadata are registered or indexed in a searchable resource. It sounds simple, right? You just register your data and search by any like mechanism, but there is more than that. So this group is focused more on from users' perspective, how to define the discover data and how the service operators manage their resource in a way enable researchers to find data. So here is the research, ecosystem. Our surveys have to embed it in this research ecosystem. First, why users or researchers come to want to discover data? They have a context. They have a research project. They want to find a data set that's relevant to their research project. And also person come in different skills of finding data. So how we accommodate that context into our surveys, so to support a better user discovery interface. And then we have the data providers, curators. They describe their data in metadata record and make those discoverable from the surveys. So how do we describe and annotate in the way so the surveys could provide more functionalities to support the user's data discovery context? So that's the picture this group is taking from all those perspectives. So the objective, we have two objectives for this data discovery paradigm interest group. So firstly, we want to provide a forum. Each of those stakeholders in that ecosystem I talked about can explore shared issue of how to improve data discoverability. And secondly, through our discussion and shared view, we want to produce actionable recommendations for all stakeholders to improve the data discovery experience. So this group actually formed a long time ago. It is started at plenary F, that was 2016. We organize the group activities into subtasks. So we start with these 4 subtasks. Talking about general guidelines to make data findable that lead to the 11 quick tips for researchers to find the data that Bridget talked in earlier session. Then we also collect the user cases. We collect about 75 user cases from a range of stakeholders. Then based on those user cases, we made an arrangement how make for data catalog or service operators to make data discoverable. So that's our 3 kind of supporting output from previous 4 task force. When that task force finished, we start another 3 task force: metadata enrichment for data discovery on granularity that spun off as a working group. Bridget was a chair of that working group. They produced, what is that called? Endorsed output that you can check and see how do you describe your data at a different granular level. And then another task force using schema.org. Schema.org is a generic schema to describe a resource that's also including data. So we make recommendations there. It spun off as a working group. It produced endorsed output you can check out. And that group closed at plenary 18, then we start another task force, user study of data discovery. And that we produced the supporting output early this year. And then now we start a new task force, AI for data discovery. Hope that the topic will, you all have interest and join force to work on common issues. Sorry, that's output card in the slides. Slides is available from collaborative notes. So all links there. So yeah. So early this year, we produced 10 principles for make data discovery. It is still put user in the central stage. So I'll quickly go through. You can read the output that's in much detail. So we have 10 principles. It's not just a principle. For each principle, we have recommendations. For example, the first principle is you need to know your user, who the user your service, you are going to serve them. Then the method, how do you do user study to know what their context, why they need to come to your data repository, search for data, for example. So for each of these recommendations, there are a range of examples you can have a look. That's a best practice. You can have a look. So it's very implementable kind of principle and recommendation. So if you are intended to implement any of those, I wouldn't aim for 10 at the beginning. Just pick one, what is applicable to your repository you want to implement. We are all here to, working together, help you to implement, okay? So, yeah, so there are principles for data curators, service providers, range of them. So I don't go into detail, so you can read the output paper. So as I said, the 10 principles and the recommendations is basically to improve the usability and the efficiency of data discovery. And by doing so, we also improving FAIR, and also improve user discovery experience. Okay, any questions? Any questions? Sorry, this link forget to change, but yeah.
So, thanks. So I'm checking if we have any online questions already. So no online questions. So anybody here from the audience having a question for Mingfang? So looks like no more questions. So we are now proceeding with the next talk, which is about use cases of applying large language models in enriching metadata. So this is presented by Mingfang and Amir. Amir is online. Amir, can you say something?
Yes. Well,
okay, perfect.
Yeah, I'm definitely online.
Okay, yeah.
Thank you. Okay. So next we have two presentations. One presentation is apply AI to improve data quality. That's more about how to improve metadata quality to make data discoverable. Then second presentation will by Bridget. That's more the user front, how to use AI at the user front to make data discoverable. So yeah. So in the use cases of applying AI in enrichment data, I will talking about a use case of use large language models to annotate data with existing classification schema. And while in Amir's talk will be more like find the common topics and from the data set. So no existing schema, but find the existing vocabularies or topics. So one is a top-down approach, another is the bottom-up approach. So this work I'm to present it is in collaboration with Shi Jian and Xiu Zhen from Royal Melbourne Institute of Technology University. So the example we use is Research Data Australia. That is a national research data catalog offered by Australia Research Data Commerce. This catalog has two major components. At the back end, there is a beta registry. We harvest metadata from about 100 research organizations, government agencies, and cultural institutions. And at the front end, what you see, the screenshot is a discovery portal. The discovery portal use the subject headings intensively for browse around the catalog, and also use the subject headings in facet filter of search result, or you can compose advanced queries by subject headings, and yeah, you can use when you display record with subject headings, you can also do facet search to find the record from that subject area. So the subject classification schema we are using is called Australian and New Zealand Standard Research Classification for field of research. From 2020, 2022, we have a new version now, but this one experiment we did is based on the previous version, 2008 version. So the Australia government and all university use these schemas to classify research output. So that's why we choose this, but our catalog support a range of discipline-oriented subject headings as well. So I wouldn't go to detail. So the classification schema, there are 3 layers going from broad go to more narrow ones. So in our experiment, we just started with this top layer, 22 subject headings. So at the time we did the experiment, we took the portal has about 200,000 metadata record about data sets, but is less than half of that annotated with subject heading. So the other half does not have subject heading, so we missed all those discover probability like a facet search, facet filter, that would enable to apply to those one without that no subject headings. So that's our motivation why we want to do this experiment to able to automatically annotate subject headings. And also the distribution of subject heading also varied from discipline to discipline. Some are very well annotated, some discipline almost none. So that's what later on you will see why the machine learning and AI performance for those unevenly distributed. So we actually tried 2 machine learning models. So we tried in 2021, I think earlier before the large language model available to public, we tried a traditional machine learning model. So basically for traditional machine learning, you need a labeled data to train the model, then test the model. Then when you're confident that precision record above a threshold, then you apply the trained models to unlabeled data, then your data then get labeled. But since 2 years ago, we have this availability of large language model to do in-text learning. So basically, you need 3 components to do the in-context learning. So you need to have a pre-trained large language model. Then you do the prompt engineering, tell this model what to do. And there are also inference components. Based on this model and this, the model doing some inference, then you get data labeled. Now in last 2 years, we have public and private the pre-trained model available. So that makes us feasible to apply to do this. So that's an example. We want to use the large language model to annotate our record with subject heading. So basically it has 3 components. So this component, you describe what task you ask the model to do. Say, I want you, to determine categories of data set. These are the categories you are going to apply. Then we give the model examples. Here the probably not seen from it's hard to say, but the slides is available. We give the title and the description and give the already labeled label. Then we give rules. When you do classification, what kind of answer we expect, what is the length, and then we give the data set we want to annotate. Then the model generate output like this. Here, say, based on this information provided, we think these 3 labels apply. So then we don't do that in the interactive user interface. We put all these instructions into the APIs, and we use ChatGPT, so we use ChatGPT API. We tell them model the message that are just shown in previous one, and also parameters. Then, to basically, So here is the result. We choose 2 models. We test 2 models. One model is, when they generate output, they randomly select the examples we provided. And the relevant one is when we give a data set, it chooses most relevant examples, then embedding some quality queries and content for the models to do more in-context learning to generate output. So this blocked the average. And basically, let me see what's the number here. I couldn't see here either. So basically, the between these 2 models, relevant one, don't worry. Oh, yeah, that's much better. Thank you. So the average, okay. So the relevant one works better with the little bit embedded text, embedded learning, perform a little bit better than random ones. But still, you see the performance varies from subject to subject, and if compared to the traditional machine learning ones, so probably I didn't make it clear before. And this model is based on all public available data, is generic one, the whatever ChatGPT trained their models on. But this one model is trained from our own data. So you can see the performance here is not necessarily better than the traditional machine learning algorithm. However, in certain categories, when the category does not have much training data, you see the subject heading, the uneven distribution before. Some categories, we don't have much training data. In that case, ChatGPT worked better than machine learning ones, traditional machine learning ones. now. Thanks. Okay, so the previous, sorry. The previous, the number here is a precision. So when model generate output, we compare with the human labeled one to see if the machine generate one is correct or not. Then there is an issue with this kind of evaluation. For example, this category is called a historical archaeology. So this one is correctly labeled one, but we have many, have many record annotated in other heading. So we did have a look of the record itself. Like, for example, this record is from a state government archive agencies. So all records sent to them is for historical reason to archive. So with that nature, they labeled all their data with these labels. But if you look at really, the content itself is talking about agriculture stuff. So when the machine learning actually labeled that as agriculture and veterinary science. So that's also, we need to look at the evaluation itself, So yeah, so but for this one, so that's an evaluation issue. But there are also issues like history and archaeology ones. These the ChatGPT perform very badly, but if we have lots of record in our repository, so that's why the traditional machine learning model performed almost perfect. So that means when we use larger language models, we probably also embed that kind of knowledge from not only from public data, but also from our own domain-specific data to train model in able to perform better. But there is also other issues when you have the labeled data from machine. How do you display that? How do you use it? So in our initial prototype for this record, we just display, these are 3 machine labeled one. But when we have a user test, we have this actually the research itself said, I don't work on this area. These 2 are correct, but I don't work on this area. That make me distrust the data you're having. So because we have a strong statement from users like this, we need a cautious. First we need to do rigorous evaluation. You need to ensure your output beyond a threshold to use it. And then secondly, when use it, probably we need to display separately. For example, have a label says this is machine generated to make it transparent to the user. So yes, that's the lesson learned. We from the use large language models to annotate the existing data set. The next user case will be by Amir Ayani. He is a professor from Swinburne University in Australia, and he will talk about another approaches. Amir, it's over to you now.
Thanks, Ming-Fang. Let me share my screen.
No, Amir, you were not able to share your screen. You just asked me to move to the next slides.
Okay, sure. It's a traditional go next. Okay, thank you.
Yeah.
So thanks, Ming-Fang. So following what you said, this the second kind of presentation is about the bottom-up approach. So this is where we actually try to build up the taxonomy using the content that we have. This is basically going to the research information and try to identify what these projects, datasets, publications, outputs are about. So we're basically trying to understand the taxonomy out of the data, not the other way around. So, I mean, Frank, can you go to the next slide, please? Okay, so and just a bit of background. This work is part of a program that ARDC, or Australian Research Data Common, runs in Australia. It's called Research Link Australia, or RLA. So the goal around the Research Link Australia is to connect industry and research together. So it has multiple different components. One of it is a data component, which basically builds a data bridge, enabling the researcher to find business partners that can contribute to their projects, and for businesses, companies, and governments, enabling them to find the right research capabilities in universities to contribute to the required innovation. So we are in a space here that we really, well, our goal here is information discovery. So it is less about putting the projects into the right bucket and more about describing overall that what these research capabilities are. And that's hence the topic of this presentation. Next, please. So just kind of on the formation of this project, just to explain how it worked, we took the approach that we call the data co-op, the data collaborative approach, and we took in this project, we had a collaboration of 6 not-for-profit organizations. We had not-for-profit entities that work with vulnerable communities. We had a medical research institute. We had a health research institute in a university. We also had an entire Griffith University in Queensland, in Australia, who participated in this activity. So we had a different level of granularity. We have partners from different types, so from the external not-for-profit company all the way to a kind of a whole university space. And this is by design. We intended to actually understand like how these kind of models can work when you actually bring different players in the field together. But the focus was health. So health and well-being is the focus of this research, and we're trying to enable this kind of matchmaking between research and industry in the health space. Next, please, Nirfan. So the process that we kind of took this project together is called data co-op. The way that it works is that it is a series of co-design workshops when we bring the data from different sources. So in this case, there is a whole data set from RLA that comes together. I'm going to explain what they are. And then we basically had data from partners. And then we take these data to our data engineering group. They produce a lot of data insights. We take these insights to these workshops when we basically do a process we call data walk. We get the participants to forming the discussions around the data sets that we have. And in this case, this is all about the research capabilities. We learn from them about what is needed, and we basically incorporate this conversation to produce better and better kind of outcomes and insights. So it is an iterative process aiming to answer the questions that we have. So in this case, the questions are about identifying research capabilities and painting a picture of collaboration network across all of these partners. Next, please. So at the case of the partnerships for this group, the data that they have collectively together, it consists of about 22,000 researchers. These are the number of researchers in their network. There are about almost 3,000 grants and projects, about more than 8.5 thousand research outputs, including publications and other type of outputs. And also we have identified about 5,800 organizations in their network. So this is just their collaboration network. It's a private data that comes from their own research ecosystem. And then what we have done is that we have augmented this information with the data that comes out of the Research Link Australia. Next slide, please. So Research Link Australia uses the research graph model. If some of you might be familiar with that, it's basically connects the multiple different research objects together. So it links the researchers to organization grants and publications. It has a not basically for researcher, the core point is ORCID. Then it connects to the organizations that come from multiple sources. It connects them to the Wikidata records, to the ROR identifiers. It has a lot of connection to the cross-ref funder IDs and also to the ABR, which is the Australian business number for entities. Again, at the same time, we have connections to other HEAT ecosystem or persistent identifier ecosystem connecting to data side, PubMed, Crossref for research outputs, and also funding information in Australia. That's we have two main funders, ARC, which is Australian Research Council, and NHMRC, which if I'm not mistaken, is National Health Medical Research Council. So we basically put all of these things together in a graph structure that actually forms RLA data, and that's what we use to provide kind of augmentation around the private information that we had from the partners. So now the next question is that we had all of these data sets, what we are going to do to identify the capabilities of these partners, and that's going to the next one. So the aim here is that, if you go to the next slide, we try to use the LLM to, we try different models, and this is at the core has been a bit of exploration, trying to find the best approach. We try to actually use large language model to construct a taxonomy out of this. And if you recall that thing about the workshops, in those workshops, we continuously got feedback from our partners about how these things actually works. One of the things that we learn is that if you put all of these projects together as a one big bucket and then apply LLM to that with right prompt engineering, you can actually get the overall classification of topics. So in our approach, we landed on like 4 main categories that are about health and well-being, about social services and community support, environmental sustainability and innovation, and technology and data science. So each one of these have subcategories. These categories are basically provide a bit more detailed concept around each one of them, but also show some focus. So if you look at the health and well-being, mental health is one of the things that pops out. And the reason is that this group collectively have a lot of research background and capability in mental health research, but also that comes with some other kind of coarse-grained layers like the physical health or health system. So overall, it tries to provide a taxonomy that explain the group together as a whole. So if you go to the next slide, now we, in the process of doing this, one of the ways that we actually optimize this classification is testing the data based on individual projects. So we have actually a pipeline that check every single project against that taxonomy, and it basically drives a probability value out of each one of these links. It basically tries to find out for each project, can I find a highly probable area that this project belongs to that? And this is the optimization layer here involved. But going back to that conversation around the co-op workshops, that's quite essential because that's where we actually get the real feedback. So although we do this a bit of a statistically, trying to identify the most optimal model, but at the same time, we continuously getting feedback from experts. And that's where really the concept of augmented intelligence come to play. You have the AI in one side, but also you have experts in the other side to guide you if you're walking to the right direction. Now, this provided at the end that taxonomy that I kind of presented in the last slide after kind of fine-tuning. Now, when we kind of paint the picture of this, and by the way, I forgot to mention that we produce a lot of these kind of visualization for those workshops. So we use a research graph insight engine that produce these kind of visualization, and we basically use these to inform those conversation in the co-op workshops. Now, in the kind of classification here, one of the kind of insights was around this focus area, and then we looked around this partnership for every single group. So if I go to the next slide that zooms into this kind of group, yeah. So as you see, although there are 4 classifications, but the diversity across partners are not all the same. So Origin, which is a medical research institution, is more about health and well-being, while the digital health CRC, which is our last item in this graph is more about a technology and data science, which is painted with red. So there are different spectrum of how these topics are distributed across this group. And this is where we kind of, as a group, we landed on a kind of understanding that this taxonomy speaks to the actual strength of these groups. So it was very much feedback driven until we got to the right point. So we had a big picture view here. We can see exactly how these kind of partners can be compared, but still this is not good enough to describe exactly what Origin does, or what, for example, Hill Network does, or what HRI does. So then we need to go one level in, or step more into the detail. So now the next step is that we basically try to do the same exercise, kind of, but without actually going for all of these projects together. So in this step, we just use the projects for one partner, like in this case about all the projects for Origin, which is about 196 projects. Now we almost try the same exercise, but just with that partner, and now we are getting a more refined and nuanced classification. So here, rather than just health and well-being, we get things like the digital and virtual investments, innovation therapies, innovating therapies, pharmaceutical intervention, youth mental health. So it's much more refined. And then under each one of them, there was a lot more detailed classification that described exactly what Origin can do. So if you go next, we can
Amir,
see...
you need to speed up a bit.
Yes, sure. We actually have 3 slides to finish. So we have, if you fit in this one, there are the diversity of the groups, and these partners now look very different as we kind of look across all of these projects one at a time. And I think this is kind of gets me to the last final slide. Okay. The findings that we have out of this very limited study, in fact, please, let's go to the last slide. Okay, so basically, I can just say that what we learned from this very, very limited study, which is only like 6 organizations, was the overall abstract taxonomy is very useful to give a comprehensive perspective of the project. However, to get a refined result, we need to actually go to the individual groups. The hybrid method is what you want when you kind of mash up these 2 models together. And the hybrid model works very well when you have the experts in the loop from that. So that's basically the final message. If there's any question, my email is on the screen, and I'm looking forward to see if you are interested in this kind of activities. Thanks a lot, and Ming-Fang, back to you.
Thank you, Amir, stayed early to give the presentation. And if you have any question, please put in Zoom chat for online people. People in the room, we have time Q&A later on. So let's move on to the next presentation from Bridget about talking about another use cases.
Hello, everyone. Hello, everyone. So this is about a paper that we've written about leveraging large language models for data discovery. Originally, I wanted to say like, oh yeah, and also we got accepted at Chi, except that we didn't get accepted at Chi. So we will publish it somewhere else. So yeah, so this is research done by Tiangying Chen, who's a postdoc working with me, Kevin Schott, who's a PhD student, myself, and Dagmar Ken, who's also a colleague at GESIS. Okay, let's get started. So since there is more and more data, which all of you guys know, being able to find data becomes relevant because you can't just go through the data catalog and pick out everything. You need to have some sort of help to get through everything. And there are tools that a lot of people use. Google is one of them. We can go on GitHub to find stuff. And there's also lots of discipline-specific portals. Some of you are maybe even doing some of these. But there's limitations. When you look at the requirements of what kind of data you typically need, it's very complex, it's interconnected. You might want to be looking for data that is interconnected with other data, or you want to have, for example, I'm working in the social science, so a very common thing is I want to have data where a specific question is being asked, or where a question is being asked that is relates to a certain topic that I'm interested in, and so on and so forth. And so the idea would, so the dream for social science at least was always to have some sort of interactive sort of system where I can, input that. And we have been trying to build that for, I don't know, 10 years or so. And then someone, started having the idea. You can have this thing where you can, like just type in stuff and it answers back. I don't know if you heard about it. It's called ChatGPT. And we were like, huh, okay, that looks like a good idea. I mean, and it works. So maybe that also works to solve some of the problems that we have with data search. Yeah, so as a lot of research shows, conversational agents such as ChatGPT or Copilot have a lot of capability when it comes to information retrieval. There are also some dangers involved in that. I'm not going to talk too much about the dangers here, since we're mostly interested in the opportunities, not so much in the challenges. Okay, this is some of the, oh no, the text is cut off. Well, anyway, this is some of the related work. I mean, this is a research talk, so I got to talk about what other people have been doing. We have models that relate to search behavior and cognitive emotional. That's interesting. I don't know how that sentence ends. Load, I would guess, but doesn't start with an S, so I don't know. Anyway, so you have very traditional models that are also used in library science, going like what is the search behavior, what is more difficult, like what do you, where do you have to think more, if you do it that way or you do it a different way. Then we have to, the difficulty is, like if I have a data set, how do I know it's the right data set? So suitability is a thing, and so we're looking at what kind of information is needed there. It's a well-known problem. There's also all kinds of literature about that the metadata is often not sufficient to actually answer whether or not this is a piece of data that I can reuse. There's all kinds of information. One of them is, for example, what is the quality of the documentation? I mean, no metadata actually says that. If, is it good enough for me to understand? Like, who would put like, no, we have the data here, but the documentation is crap, so don't use it. It's a personal assessment. And then we had some recent studies that LLMs can outperform traditional search engines in specific domains with specific questions. Not always. But of course you have the one on problems, hallucinations. I had that myself. I was trying to find a data set which I knew existed, but I wanted to know something about the data set. And then ChatGPT just made up stuff. Like I was asking, okay, is this variable in the data set? It's like, yeah, sure. It's like, okay, where is it? And it's like, yeah, to try this website. And I click on the website and it goes like, it leads to nothing. I was like, okay, this is wrong. So hallucinations are still an issue. Sometimes the data information is outdated. We all know that ChatGPT in particular was not updated recently, and there's biases. All of that is, of course, a moving target. They recently introduced online search in ChatGPT, so the outdated thing is still somewhat an issue. But yeah, I'll talk about this a bit later. Okay, so what do we try to find out? So one of them is, so the people that work with are psychologists. So they're not interested are LLMs good, but they want to know, are they going to be perceived as good? So in a way that I had to wrap my mind around this a little bit, but the idea is that instead of just saying measuring how long does it take to find a certain thing with ChatGPT versus other? You go like, okay, do the people who use it think that it has been useful to them? Because and that makes sense because if people don't think that the tool is not useful, they're not going to use it. And then it doesn't matter if it's actually more useful than something else. It doesn't feel like it. And so the adoption rate is not going to be good. So framing this slightly different, saying like, okay, how do people, feel about the trust and usefulness is a very important thing. And I think there's a chat thing. Can you check the chat? I think there's someone. Nothing about me. Okay. Okay. So this is one thing that we were trying to look into. And then, of course, the other thing is like, what is the mental effort required to use one thing or the other? And also, is it different? So obviously, in a way, Google and ChatGPT are very similar. You type in stuff, you get information back. But in many other ways, they're not. So what we're trying to do is to figure out what exactly the differences are between these two. All right, so this is the method slide. We did a mixed method study. Mixed method just means that we gave them a survey where they had to fill out stuff, check boxes, and we also did interviews. We were looking for people in data science and HCI, mostly because the people I work with are working in HCI, so they basically called all their friends and forced them to do that, I think for beer or something. And they were recruited from the US and Germany. We originally wanted to use ChatGPT, but then we found out that it's actually pretty difficult to do experiments with ChatGPT because people would have to use their personal accounts, and that gives you all kinds of difficulties. And also, the personal accounts obviously are preloaded with personal information about this person, and that makes it all very tricky. So to make it fair, we used Copilot, which, at least in theory, should be the same thing. Okay, so here is Copilot in case you have never seen it. It is very similar, right? So you can just type in stuff and then it gives you an answer. But I think by now everybody has been using these sorts of things, right? Okay. I'm glad. I recently asked my dentist. I told him I work with stuff like ChatGPT, and she said like, I've never used ChatGPT. I was like, oh my god. I guess you can get away with that if you're a dentist. Okay, so next slide. So what is the experimental design? We have a search task, and they have to do it with Google. So one example is we had a bunch of questions, I think about 20. What is the impact of healthcare spending on life expectancy across Europe across the last 10 years? So this is a complex query in a way, because you have to have, in many cases, you would have to have two data sets, one of them for the life expectancy and the other one is for healthcare spending, and then you have to kind of like mash them together to get this information. Yeah, and you have, additional constraints, like you have Europe and not the rest of the world. You have last 10 years. So there's all kinds of, additional constraints on this. If you wanted to put that into a database, queries like that are hell, because you usually wouldn't get an answer, because there's probably not a single data set that actually answers all these questions. So people would then just try to do that with Google, and we would ask them to think aloud, like comment verbally on what they were doing and recording that. And then we would give them a questionnaire, which basically gives them a lot of standardized questions. And then we would ask them to do a different thing and do the same thing with Copilot. And the same thing, they were supposed to comment on what they were doing. And we recorded what was happening, and then we gave them another questionnaire. The questionnaire was about trust. So all these are, since I work with psychologists, they always want to use like these standardized scales. And the one that we picked out was trust, perceived usefulness, and mental workload. And all these are like super well tested and well documented and stuff like that. And then there was a follow-up interview. And here are the results. So result number 1. Working with Copilot is actually less stressful, or has lower mental workload than working with Google. So there we go. This is the chart for that. We also had some other design results with that. I think this is one of the reasons why we didn't get accepted, that we should have worked more with that. But anyway, I'll tell you in the next paper when we actually do get published. Anyway, so what does it mean? It's easier. You don't have to think as much. With Google, you really have to be smart about making good queries. With Copilot, you can be stupid, right? And you can be iterative. You don't have to be smart about doing it, and so it's easier. It's nicer, right? That's the main difference. And then the second one that we found out mostly through the interviews was when we asked people like, what do you think? And people were like, I don't really trust these recommendations. They give me data, and I don't really. I don't want to. I want to double check everything, right? Because if you're a scientist and you want to work with data, you want to make sure that this is good data. And this is one of the quotes. So the things that provided may be useful or not, I'm not sure. Also, I'm not 100% sure whether it's a fact or hallucination. So I need to check everything. And I mean, this is, in a way, it's also true for Google. I mean, when you get the results, you look at them, and then like the first 5 results you just throw away because from the snippet you can tell it's nonsense. But the problem with Copilot and ChatGPT is that it always presents it like, yeah, here's the answer, and then you go like, no, that's not the answer, but thank you for trying, right? So there's the thing. So and then there's another thing that came out in the interview, which is that users appreciate the autonomy Google provides, even if it requires more effort. What is meant with autonomy? So with Google, if you think about it, you can be very precise, and you can make very good queries and then get exactly what you want. And with Copilot, it's a bit more fuzzy. There's a very long quote about this, and it was basically about one person just complaining about the user interface. Now, I work with LLMs now very, very extensively, and whenever I do user studies with them, I feel like 80% of the problems people have with them is that they are not really used to that interface. So from my point of view, it was really like a lot of people were just used to using Google and other sources, and didn't really like the interface, and also couldn't really work out the kinks. So they felt like they had less control. And that is, I think, a valid point. I mean, if you are riding a lot of bicycle, then you may be uncomfortable driving a car. I should have thought about that metaphor maybe a little bit more. But yeah, so that's it, just more comfortable with what you're used to. And then of course users interact with search queries differently. And here's the thing that I talked about earlier, that when it comes to Google, people really need to think about how to do the query, how to trick Google into telling you what it means. And Copilot is different. Like you can always make like small adjustments. And you can be more specific in a certain area, and you don't have to repeat yourself so much, because every Google is basically a new input that every Google query is a new input that you do. And when you work with Copilot, it's kind of like a history, like it knows what you did before. Yeah, so that's how people felt about it. And yeah, also that they like the guidance provided by Copilot. So they trust. Oh, okay, so I should stop. There's another long quote that you can read. Probably faster than I can, read it out loud. Okay. So, in conclusion, so conversational agents like Microsoft Copilots are more effortless. They support experiences, but there's a little bit of a challenge with trust. And we think that it's a good complementary tool to traditional search engines. And one thing that we do is that we're going to show this to my boss and ask for a lot of money to build our own LLM. So that's the next step and the future. Thank you. Okay, so back to the agenda.
So thank you. So the next on the agenda would be some discussion and feedback. So we have a lot less time than shown here, but I think we should start. So the first thing that everybody is invited to do is now to scan this QR code. Unfortunately, I have to. Where's the mouse? Here. So to scan the QR code and visit the Menti page, where we would like to discuss with you several questions how we could proceed in this working group. And the first question is, let me change to Menti here. So to stop the screen share. No. A minute, I need to go to the browser. So present, yeah. Okay. So the first question is, yeah. The problem is, yeah, go to menti.com and then enter that. Unfortunately, it's hard to do that in parallel. Yeah, that applies to current projects. Yeah, I repeated it. 655 3 1 3 2 1. Can you post the link in the chat for the other ones? Yeah. So it would be good to know some projects that you're currently involved that would really apply for AI and usage of data discovery. So yeah. I think it could be both. So AI for data discovery also involves like the first presentation we have seen where you are trying to use AI to improve the metadata, for example, of your discovery. So that would be one example, or others would be like have seen in the second presentation, something how you could use AI for the discovery purposes. Yeah.
But these are not ideas. These are things that we know already are in existence. Yeah.
Are you involved any projects that apply AI? Not necessarily LLM or ChatGPT, any kind of machine learning to automatically improve the metadata quality, or at the user front, like Bridget just presented, you know, any.
So I was just wondering, I have used in some of my projects discovery, and in database speak, what I'm doing is I'm taking existing data and creating derived data from that data by using AI, and then I put it back in the database. So the issue here could be is, sort of circular logic, and I'm wondering, are there any efforts to maybe create a standardized protocol or language to describe which data is primary, which is generated by AI? Then you can take the AI generated data, further refine it by using other AI. So maybe you can talk about it a little bit.
So in that case, you know, when you create metadata for your derived data set, you could say, you know, if your metadata has a good schema, so it would have relation. This data set is derived from that. But without that description, you know, you can use machine learning to check the two data set to compare the bit stream, you know, how that two related. Yeah.
So to kind of add to the comment there, I think for traditional AI ML, right, what Mingfang said is all right, but for Gen AI, where the data that's generated does not pre-exist, but it's built out of existing data still. PDB, which is the Protein Data Bank, has a good mechanism where they have structures that are experimentally confirmed, and they explicitly mention that these structures are experimentally confirmed, whereas those that are generated out of, you know, the Gen AI or modeling, they explicitly also tell you that these are outputs of the AI, like what Mingfang was talking about, and that this data has still not been experimentally verified.
PDB and other researchers in other fields can come to a joint standard of some sort where you label primary, or maybe it could be called human data and then AI data, or human generated and AI generated. But yeah, thank you.
Thank you for your own, like for if you have your own data set to train, that's, you know, easier you point to that's, you know, raw data. But you, like Anu said, if you use ChatGPT, you don't know which data set they train on. So that's hard to, you know, you can say it's from ChatGPT, you know, version 3.4 or 3.5. Yeah, it's up to them if they can tell you what data set is they train on. Okay, probably we move on to the next question.
So should we list them here? No, I think let's go to the next. Yeah, we have a lot of, yeah. So we have a lot of questions. So this looks like a project title, AlphaFold. For understanding research terms and looking for literature research related to ours, but not the core of own expertise. Yeah. Oh, that's also interesting. Augmentation or simulation of data points for sensitive data. So we use AI pooling similar consistent keywords towards a common ontology. That's also a good idea for AI mining pits. That's nice. Okay. So I think we should still move to the next one. How can I get? Here. Okay. The next question is, what are the current gaps you see in the application of AI for data discovery? This looks like good discussion topics. So what do you think at the moment is a problem when you try to use AI for data discovery. So what's your issues you see at the moment? Yeah, challenges. This too? Oh, we get a lot.
I guess we can sort of continue on the theme that we talked about before. But I've seen that people don't store the original prompt with the data. That could lead, you can see how it can lead to a lot of issues because, you know, we all probably know like how you can play with, you define a role for the AI in the prompt, and depending on that role, the results will be different. Another challenge I've seen is, so like you mentioned, 3.54, there's also subversions. So like if you prompt Gemini, for example, through the API, not through the chat interface, but through the API, you know, they just came up with 1.5 Pro 002 before it was 1.5 Pro 001. And if you didn't record that change, you'd get a better result probably, or a different result, but it's just a different system altogether. So it's important to, yeah, record all the surrounding metadata, including all the details on the version, the prompt details, the system prompt detail, the system message details. Yeah, anything you can think of. Yeah. No, yeah, go ahead.
I'm just saying that could be a good activity. There's no standard way of describing that. So some people capture some things, some people capture other things. But standardization of that type of metadata could be useful activity.
We also have some thoughts from the other people here. So, for example, metadata usage to leverage AI capabilities was mentioned. Mitigating the hallucinations, yeah, that's always a big problem. There are ways to do that by possibly not, for example, directly returning the results from the ChatGPT to your end users and somehow filter it before and then, for example, do something. That's a nice thing to see. Data to be discovered, not described. So was it here from somebody here? Yeah. Are not a LLMs, Gen AI are not a search engine. They don't find data, they pretend. That's a good thing here. That's one of the problems. Lack of description verbose enough to be mined. Removing thought process for research. Yeah, people is a gap. Yeah, that's right.
I don't know. Do you want to elaborate on what do you mean? People is like skills or validation, or you know, what do you mean?
I don't know. Yeah. Hmm. Maybe add another answer here to explain that if you're online. Yeah. Yeah, the next one is, which are the possible challenges that you can identify in this context?
improve the data discoverability, like the 3 use cases we give, either user front or in the backend, whatever. Then
Yeah. Who is going to pay for that? Yeah, with the commercial AI, there's problem of paying. Time to figure it all out. Yeah, that's. But time to figure it all out is maybe we need some additional 10 recommendations for applying AI in data discovery. How best to harness existing metadata for discoverability. Yeah. Trust. Yeah, that's good answer. Yeah, yeah, Con.
Just wondering, like, who would be the end users of these services? Like, who do you have in mind? Like researchers or researchers, the kind of end users that you have in mind for these services? Who are the end users that you have in mind? Their users. Who are the users that are in mind for these questions?
sorry, you say who are the users?
Yeah.
Oh, right. It, it's whoever come to your data repository. You want to, they will use whatever, service you improved, including, you add a AIM component, for example.
Maybe not necessarily along these lines. I had actually 3 questions for the 3 presenters. Can I ask? So Ming-Fong, you presented, GPT 3.3 and 3.5. So was it just out of the box, or did you do any of the prompt engineering methods like RAG or chain of thought, or was there any mechanism that was utilized for doing the prompt engineering, I guess?
So we use 2 type of prompts. One is like a random, one is relevant one, but we just use these 2. But there are other ways, and also like at that time we that was the latest version we available, but now there are 4.0, you could compare. And even in that 3.5, there are lots of variables, parameters you can choose. For example, one parameter, I didn't get time into that, is choose the, what's the randomness? Like, do you temperature? Thanks. So if you target the high precision, or you 0, or you target it to high creative creativity. You know, if for the creative writing, you probably choose high temperature. For us, aiming to high precision, you probably choose low score. So lots of parameters to test about, but yeah, we didn't. And also another thing is we with the result we just choose the samples from our repository. If you want to test all your repository data set from your repositories, then you need to pay more money. More question. You have three. That's
So for Amir, he talked about taxonomy generation, right? And he showed results which were in distinct bins. So I wondered if he had looked at multi-labeling, right? Instead of labeling a grant as one single into one single bin, one single taxonomy, whether you could potentially, if there's something that's, you know, interdomain work, whether it would get bent into both of them or whether a new taxonomy was getting created, I guess.
so. Amir, did you hear the question?
Yes, I did.
Do you answer?
So the short answer is that the entire thing, the entire model is basically multi-labeling ecosystem. So every project in a taxonomy structure like this is connected to almost every other topic with a level of probability. So as if you build a taxonomy in a very closed environment and there's not enough distinction between these dataset projects, publications, and grants, there is a level of connection across these taxonomy. What we have done is that for the simplicity of conversation in those workshops, we took the most probable one, so that makes the conversation easier for people to digest. But it's very easy to implement this kind of visualization or labeling system on a potential repository that shows maybe top 5 or top 6 category across each of these projects. Again, grants, publication, datasets, each one of them can be multi-label.
Yeah, so it's feasible, but in that project, just the level 1 level, topic 1, and also there are also questions. You know, those those projects are most funded project. You know, over the years, the topic can be changing. There are also questions like you identify topic trends every like a time range just to see how the funding shifting. That's probably also new areas funders want to see. Yeah. Third question.
Third question is for Bridget. So when you were looking at Google search, was the summarization implemented already? Right now, if you go into Google and search, right, they have, you will get an AI generated summary on the top. Was that implemented at all when you guys did your study?
No, we did the study earlier this year, and so there were two things that have changed with Google since then. One of them was the one with summaries, and the other one was that Google Dataset Search is now out in beta, I think, and so you sometimes get results from Google Dataset Search that didn't exist back then. So yeah, it's all of that stuff is like really fast-moving targets. Everything evolves very quickly right now.
Okay, we have only 2 minutes left. Any like a last minute quick question? No?
Yeah. So we got a lot of answers already on the Mentimeter. I think we will copy and paste them into the collaborative notes. So because we don't have any time anymore, I would like to invite you to maybe join our next session, which will be on December 18th, which is the schedule. So you can enter there, and then we can proceed with discussing how to go on with our interest group. Yeah, Mingfang also.
You have to be group member to receive that message. So if you are not a member of the data discovery interest group, or you can just, click that join, find the group, click join button. So we have a monthly meeting, and this November one is cancelled because of this plenary. But the going forward, we will see what kind of activities around the discussion we have here today. So we create a task force to working forward.
Yeah. So see you on December 18th, hopefully. So please register and attend our interest groups so we can see you. Yeah. Okay, I think time is over. 4 p.m. Yeah.